Hi, ninth grade friends. We are having our test on system of equations on Friday, and you need to be able to solve a system of equations using graphing, solve a system of equations using substitution, solve a system of equations using substitution. You also need to be able to solve a system of linear inequalities. So I have put together an ALEKS assignment that helps you practice all of those things. Make sure that you are showing every step of your work on a piece of paper, and you will need to turn that in so that you can get credit for your ALEKS assignment. Your ALEKS assignment does need to be at 100% before you can take your test. So with that said, I'm going to go ahead and get started. I'm going to show you some sample problems of each of the different types of problems that you'll see on your assignment. Okay, so one of the things that you need to be able to do on your test is you need to be able to graph a system of linear inequalities. Okay, so in order to do that, remember you're trying to find the solution to this system. So you're going to graph both of these linear inequalities on the same coordinate plane, and then you're going to see where the shadings overlap each other, and the place where the shadings overlap each other, that is your solution area. So first step is to put both of your equations in slope-intercept form, which both of these equations are already in slope-intercept form. We have y is less than or equal to negative 4 times x plus 5. We're going to put this negative 4 over 1. And to graph this line, we know that it crosses the y-axis at 5. And then we know that the slope is down 4 to the right 1. So 1, 2, 3, 4. Okay, so this is going to be my line right here. We can also move up 4 to the left 1. Okay, and I want to make sure that I get a straight line here. Okay, so now this line is going to be solid. Because it's a less than or equal to, our line's going to be solid. I'm going to try and carefully draw. It's kind of hard for me to draw on my bamboo tablet here, but we have a solid line here. And then our shading is going to be everything less than the line. Okay, so now we are going to go ahead and graph the second line on the same coordinate plane so we can see where the shadings overlap. So our second line crosses the y-axis at 7. Okay, our slope is up 2 to the right 1, or we can go down 2 to the left 1. This line is going to be dashed. Because this is just a greater than, our line is going to be dashed. And remember, if the line is dashed, that means that the line is not included as part of the solution area. So we have a dashed line. Sorry, I wish I could graph a little better with my tablet, but hopefully you can see that good enough. And then we are going to shade above this time because it's y is greater than. So everything above this line would be here. Okay. Now this area that we have where you can see the blue, that is our solution area. Okay, so if I just like darken this all in, this right here where the two shadings overlap each other, that right there is our solution area. Okay, and remember that our solution is going to be anything bigger than the mint green line and anything less than the pink line. So the place where those two overlap each other is right here. Kind of darkened that in black. So that would be how you graph the solution of a system of inequalities. You graph both lines on the same coordinate plane and you see where the shadings overlap. Remember, if your inequality symbol is a less than or equal to or a greater than or equal to, your line is solid. if your inequality symbol is just a greater than or just a less than, your inequality symbol is, your line is dashed. And then remember, if your y is greater than or equal to, you're going to shade above the line. And if your y is less than or equal to, you are going to shade below the line. Okay, the next one, solve the following system of equations. Now there are a few like this on your assignment where you have fractions in your equations. And one of the things that I have taught you to do is to simplify these two equations by getting rid of the fractions. So if we find a common denominator for all of these terms, which for the top one would be 8, because the common denominator between 4, 2, and 1 would be 8, and for the bottom one, it would be a 6. And if we multiply everything in the equation by that common denominator, it will eliminate our fractions. So if we take 8 and multiply by 3/4, 2 times 3, that will give us 6x. 8 times 1/2 is a plus 4y. 8 times -10 is a -80. And this equation, 6x plus 4y equals -80, is a lot easier to deal with than the one that has the fractions. So if we multiply everything in the bottom equation by 6, we're going to get -2x plus 1y equals 36. And now we have a system that we can easily solve. You get to pick how you solve the system. So you can either do it by elimination, or you can do it by using substitution, or you could graph both of these lines on the same coordinate plane and see where they cross. I think the easiest way to solve these two would be elimination. So in order to make elimination happen, we want, if we're going to eliminate the x, we want these two to be the same numbers, only opposite signs. Okay, so if we want to eliminate the x, we can multiply everything in the bottom equation by a +3. What that's going to do is it's going to make this right here, when we do 3 times -2x, that'll make a -6x. And then 3 times y is 3y. And 3 times 36, so we do 36 times 3, that'll be 108. And then our first equation stays the same, 6x plus 4y equals -80. And once we multiply everything in the bottom equation by a +3, we have now set up our system so that we can do elimination. So when we add the two equations together, -6x plus 6x cancels, 3y plus 4y is 7y. 108 minus 80 is 28. And now we can solve this equation for the y by dividing by 7 on both sides. So y equals 4. Now once you know what the y equals, you can go back to any of your original equations, the first one, the second one, or the one that you changed, and you can substitute 4 for the y and solve for the x. You take 6 times x plus 4 times 4 equals -80. You can now solve for the x. 4 times 4 is 16. So you would subtract 16 from both sides, which gives you, I'm so sorry, I'm running out of space here. I'm going to take this and I'm going to move up to some new space over here. So that's going to give us 6 times x equals -96. And if we take 96 and divide by 6, we get 16, -16. So -96 divided by +6 is a -16. So we know that the solution to this system is -16, 4. That's where these two lines are going to cross each other at. Okay, so another type of question that you're going to see on your ALEKS assignment is where you have to solve the system of equations by graphing. And in order to do that, you're going to graph both of the equations on the same coordinate plane. You're going to see where they cross. So the first equation has already been put in slope-intercept form. If we want to graph the second line, we need to put this in slope-intercept form. So we're going to solve for the y. So we get y equals 3 times x minus 6. And then the slope of the second line would be 3 over 1. So we're going to graph this line and this line on the same coordinate plane. Because they have different slopes, we know that these two lines are going to cross at one point. Remember, when you are solving a system of equations by using graphing, if the slopes are the same and the y-intercepts are different, you know that those two lines would be parallel. And if two lines are parallel, there is going to be no solution. And then remember, if your slopes are the same and your y-intercepts are the same, you know that you're talking about the exact same line. And so your solution would be infinitely many solutions, because that means that they would be crossing at every single point. For these two lines, though, like I said before, their slopes are different. This one is negative 1 over 2, and this one is 3 over 1. So we know that for this system, there's going to be one solution. So to graph y equals negative 1/2 x plus 1, I'm going to start at 1 on the y-axis. The slope is negative 1/2. So that means I'm either going to move down 1 to the right 2 or up 1 to the left 2. But this negative sign either goes with the top or the bottom. It can't go with both. Okay, so down 1 to the right 2, down 1 to the right 2, or I can move up 1 to the left 2. And I'm going to do this a few times just to make sure that my line is really straight. Okay. I hope that I can draw this straight with my tablet here. You have to do an accurate line because you're looking for where the two lines cross each other at. Okay, now the second line crosses the y-axis at negative 6. The slope of that one is up 3 to the right 1. Oh, that one was easy. Okay, so we can see that these two lines cross each other right here at this point. And remember, that point from the origin is to the right 2, up or down 0. So the solution to this system would be 2, 0. So if I were to plug 2 in for the x and 0 in for the y into both of these equations, this is what would make both equations true. This is the solution. Okay, so the next type of equation, or the next type of problem that you will see on your assignment is you are going to be given a system and you are going to have to determine whether the solutions that you are given really are solutions to that system. And you just have to say yes or no. So remember, if an ordered pair, or if a point is a solution to the system, when you plug the x in for the x and the y in for the y into both equations, it needs to make both equations true. Okay, so if we take 6, 0, and we plug 6 in for the x and 0 in for the y, we need to see if that makes both equations true. So 0 equals negative 2 times 6 plus 9. Negative 2 times 6 is negative 12. Negative 12 plus 9 is negative 3. So right away we know that this is not a solution. Okay, let's try for 1. Remember that the point needs to make both equations true. So if I plug 1 in for the y in the top equation equal to negative 2 times 4 plus 9, that's true. Okay, and then if I plug the same point, 4, 1, into the second equation, I'm going to have 4 times 4 plus 2 times 1 equals 18, and that is true. Okay, so this would be a solution because it makes both equations true. And for these, you are checking all 4 points and you're just saying yes or no. Okay, the next type of question, there's 2 more that you'll see on your assignment, and they ask you to solve the system of equations, and they don't give you a method to use. So you get to pick. If I were to see a system of equations like the one on number 5, the method that I would pick would be elimination. And so in order to use elimination, we want to pick whichever variable we want to eliminate, and then we have to change either one of the equations or both of the equations so that when we add the 2 equations together, that variable will drop out. So if I pick to eliminate the y, I'm going to times the top equation by 5, everything in the top equation by 5, and everything in the bottom equation by 2. That's going to give me a 10y for the top equation and a negative 10y for the bottom equation. That will then eliminate. So remember, you get to pick whatever you want to do to change the equation so that when you add them together, one of your variables drops out. So 5 times negative 7 is negative 35x. 5 times 2y is 10y. 5 times negative 13 is negative 65. Okay, and on the second equation, if I times everything by 2, I'm going to have 4x minus 10y equals 34. And now I add the 2 together, so I'm going to have negative 31x equals negative 31. And then to solve for the x, I'm going to divide by negative 31 on both sides. So x equals 1. So remember, we changed both of equations so that the y variable would eliminate. And then when the y variable eliminates, we're left with just the x. So x equals 1. And then to figure out what the y is, I can just go back to either one of my original equations or my changed equation, and I can substitute 1 for the x and solve for the y. So 2 times 1 is 2. 2 minus 5y equals 17. So then I have to subtract 2 from both sides. I'm running out of space here. So that would give me, I'm going to take this and I'm going to move over here. So I'm going to be left with negative 5 times y equals 15 when I subtract 2 from both sides. Then I'm going to divide by negative 5, so y equals negative 3. So my solution for this system would be 1, negative 3. Okay, and then the last type of question that you'll see on your assignment is to use substitution to solve. So when you use substitution to solve, remember your first step is to put the 2 equations side by side. And then you want to solve one of the equations for one of the variables. When we look at these 2 equations, we can see that this one has already been solved for the y. So we know y is equal to 3 times x minus 9. So we're going to take our other equation, our first equation, we're going to write it just like it is, but instead of that y, we're going to make a substitution. And the whole reason we make a substitution is so that we can have a new equation that has just one variable. And now we solve by distributing the 5. When we distribute the 5 to both of the terms, 5 times 3x is 15x, 5 times negative 9 is negative 45, and then we have 4x plus 15x minus 45 equals 31. Then we're going to have 19x minus 45 equals 31, and then we add 45. So 19x equals 76. Then we divide by 19, And 76 divided by 19 is 4. And once we know what the x is, we can go back and figure out what the y is, because the y is equal to 3 times whatever the x is minus 9. So we take the y equals 3 times instead of the x. We can now plug in 4. 3 times 4 is 12. 12 minus 9 is 3. So the solution to this system is 4, 3. Okay, so I have given you a sample problem of each of the different kinds of questions you'll see on your review. Please make sure, like I said, that you are writing down each question and that you are doing them on your own piece of paper and that you are showing your work. Write down each step. That's what's going to help you do these correctly. Your algebra has to be perfect. You can't make small mistakes or you won't get to the right solution. So if you need any more help, please come see me before school or after school. I'm always super happy to help you.